First World War gave birth to a revolutionary new weapon, the tank. At first, the tank was merely a lightly armored pillbox on tracks. It was slow, awkward, vulnerable with little firepower. But primitive as the tank was, it broke the stalemate of trench warfare and opened up a new concept of combat. The American tank developed rapidly in the years just prior to our entry into World War II. Design and equipment improved. Speed and maneuverability and firepower was stepped up. We were preparing a new and overpowering kind of attack. We were forging the Thunderbolt. The Thunderbolt struck through North Africa, routing hundreds of enemy tanks in single battles. The Thunderbolt slashed into Italy, Normandy, Germany. It struck everywhere. No major action in Europe was fought successfully without the presence of armor. The tanks had speed, cross-country mobility, firepower, and great shock action. They exploited breakthroughs, seized distant key points, made wide flanking maneuvers to strike deep in the enemy rear areas. They plunged through on missions requiring bold, independent action. The tanks couldn't be stopped. The modern tank is the great decisive weapon of the ground team. Its value is based to a large extent on the advantages offered by the turret. Advantages which have increased steadily as the turret has improved in design and equipment. The turret rotates at any required speed through a complete circle. This permits firing in any direction without moving the tank. It can be reversed instantly. Fire can be shifted rapidly from one target to another. The broad base of the turret and the increased slope of the armor give good protection against enemy fire. The design provides adequate room inside for equipment and crew for efficient and comfortable operation. The tank commander is in command of the tank and its crew. He rides with the hatch open, except under artillery time fire or heavy small arms fire. He observes and controls the firing of his tank. The gunner aims and fires the main gun and the coaxial machine gun on command of the tank commander. He maintains the guns and the fire control equipment. The loader loads the main gun and the coaxial machine gun. He helps to maintain the guns and the fire control equipment. The driver is in the compartment below the turret. In some tanks, there is an assistant driver who fires a machine gun. When the tank commander locates a target, he alerts the crew and gives the fire command. In tank gunnery, teamwork pays off. Crewmen must work together like a well-oiled machine. They must develop the aggressive spirit to close with the enemy and destroy him before he strikes. The first or second round usually is decisive. Two rounds and 2 hits. To ensure good teamwork, the tank commander is in constant communication with his crew by intercom and with other tanks by radio. Another target. Let's listen into the fire command.
Gunner, shot. 1,000. Tank, 1 lead. Fire.
Up. Identified. On the way.
There There are several types of tanks in use by the Army. You may be assigned to any of them, and your first impression will be that turret controls and instruments are quite different. Let's look at the controls and instruments in some cutaway turrets. They are of different types. Locations, too, may vary. Yet fundamentally, controls, instruments, and principles of operation are the same in all types of turrets. The fundamentals will be shown so that you will understand and be able to operate all turrets. These are the basic facts. There is a turret-mounted caliber 50 machine gun for use against ground targets and aircraft. There are stowage spaces in the turret bustle and along the sides for accessories such as small arms, spare periscopes, tools, and binoculars. Rounds for the main gun are stowed in the ready rack, under the turret floor, in the sponsons, or in the turret bustle. They are stowed both vertically and horizontally. The main gun mount is suspended on trunnions to permit elevation and depression of the gun. A coaxial machine gun is fixed on the mount with the main gun so that both are aimed or laid together. The recoil mechanism cushions the shock of the gun firing. A gun travel lock is provided on the rear deck to protect the elevating and traversing mechanism from wear when use of the gun is not imminent. The gun must be taken out of travel lock before it can be elevated or traversed. When the gun is not in travel lock, the turret may be locked to prevent wear. The lock engages the teeth of the turret ring gear. You must unlock it before you can rotate the turret. The turret can be traversed in two ways. The gunner uses the manual traverse control handle to rotate the turret by hand. Manual traverse control handles differ in appearance and in location, but they operate in the same manner. Manual traverse is used for short shifts or change in direction of fire, or to complete the final lay on target. The primary method of traverse when making large shifts or changes in direction of fire is in power. The gunner has a power control handle for rotating the turret in power. The tank commander also has a power control handle. In power traverse, as in manual traverse, there is more than one type of control handle. However, all are used in the same manner to control the direction and speed of the traverse. When the turret is in power operation, the tank commander, by use of his power control handle, can take over from the gunner. These are the controls whereby the turret is traversed manually and in power. The gun can be elevated or depressed manually in all turrets and in power in some turrets. For manual elevation and depression, the gunner may have a manual elevation control wheel or a manual elevation control handle. The same control is used for power elevation and depression that is used for power traverse. When the control has this double purpose, it is known as the power control handle. In most turrets, the tank commander can take over elevation of the gun when the turret is in power operation. We have seen that traversing and elevating can be done in two ways, manually or in power. Firing the gun also can be done in two ways, manually or electrically. The gun is fired manually by means of a lever on the gun mount. The primary method of firing the main gun and the coaxial machine gun is an electrical firing system. Firing controls are provided in various positions, but always on the principle that the gunner need not remove his hands from the controls to fire the gun. Any one of these triggers will fire either or both guns. You turn on the firing switch for the gun you want to fire. Red warning lights show that both main gun and coaxial machine gun will fire when the trigger is pulled. Most of the ammunition carried in the tank for the main gun is high explosive, HE. There are also rounds of armor-piercing ammunition called shot. Other rounds of armor-piercing ammunition called hypershot. And white phosphorus rounds called smoke. The loader must work close to the path of recoil of the main gun to protect him when he is exposed. Every turret has the means for manually blocking the firing linkage, so that the gun cannot be fired either manually or electrically. It is located on the main gun. In addition, in some turrets, there is an electrical device called the loader's reset safety. Firing the gun breaks the electrical circuit. The gunner cannot fire the gun electrically again until the loader resets the safety. In turrets with ammunition stowage under the floor, the loader is protected from an unexpected power traverse by a voice warning, or in some turrets, by a loader's traverse safety switch. When the switch is off, light out, the turret cannot be traversed in power. This prevents injury to the loader as he removes ammunition from under the turret floor to refill the ready rack. Switch on, light on means that the turret can be traversed in power. Now let's review the fundamentals of turret controls and their operation. The turret rotates on the turret ring, traverses a complete circle at variable speeds. It reverses instantly. The traverse may be made with a power control handle or with the manual traverse control handle. In most turrets, the gunner can elevate or depress the gun with the power control handle. In all turrets, there is a manual elevation control. There is an override control for the tank commander, permitting him to take over from the gunner when the turret is in power operation. The main gun may be fired manually, but the primary method of firing is electrical. By turning on switches, the gunner can fire either the main gun or the coaxial machine gun, or both together. In every turret, there is a mechanical safety on the gun mount to prevent firing. In some turrets, there is also an electrical safety called the loader's reset safety and a loader's traverse safety switch. We have shown that although turret controls differ in type and location, their operation is fundamentally the same. In part 2 of this film, we will show that the same similarities exist in vision devices, direct fire sights, and auxiliary fire control equipment. In part 1 of this film, we covered the fundamentals of turret controls. We will now study the components which are employed to locate the target and to lay and fire the main gun. These components are known as fire control equipment. There are 3 types: vision devices for location and observation of the target, direct fire sights for laying the gun when the target is visible through the sights, and auxiliary fire control equipment for laying the gun when the target is not visible through the direct fire sights. First, let's look at the vision devices. Each member of the crew has some type of vision device. The tank commander uses the binocular for general observation and as an aid in determining range. When it is necessary to button up the tank commander still can see in all directions through windows of shatterproof glass called vision blocks. In addition, periscopes provide various members of the crew with a means of seeing outside the tank. Let's remove one of the vision periscopes and examine it more closely. Vision periscopes have no magnification. They differ only in size and appearance. Although the crewman's eyes actually are behind the armor plate of the tank, he sees the image reflected downward from the top mirror or prism. The second type of fire control equipment is direct fire sights. This classification includes telescopes, direct fire periscopes, and rangefinders. There are 2 models of the rangefinder shown here. Direct fire sights vary not only in type, but also in arrangement in the turret. In any turret, the gunner has 2 direct fire sights. There may be a direct fire periscope and a telescope, or a direct fire periscope and a rangefinder. If one is damaged in combat, he still has the use of the other. The tank commander has 1 direct fire sight. It may be either a direct fire periscope or a rangefinder. Let's consider the gunner's telescope. The telescope is mounted coaxially with a main gun. Therefore, both are elevated and depressed together. In the lens of the telescope is a pattern of lines known as the standard dash pattern reticle. The cross at the top is the bore sight cross and represents 0 range and 0 deflection. When the gun is bore sighted, the cross shows where the bore of the gun is pointed. This reticle is graduated for shot ammunition. but is used also for firing all other types of ammunition. The cross is now laid on the tank. When the gun is pointed directly at the target and fired at this range, the projectile will fall short due to the effect of gravity. To compensate for this, determine the range or distance to the target. Here it is at 1/600 yards. Then elevate the gun until the 1/600-yard range line, indicated by the number 16, is on the tank. The projectile will now carry to the target. In firing at a moving target, you must aim ahead of it in order to hit it. The lead lines help you to maintain the correct amount of lead. The second type of direct fire sight is the direct fire periscope. The periscope is so linked to the gun that only a mirror in the head of the periscope moves with the gun. It has a reticle normally referred to as the sagebrush reticle, with a fixed aiming cross in the center. The reticle is reflected into the mirror in the periscope. The vertical lines are range lines used to make changes in range. The horizontal lines are lead lines used for firing at moving targets. In setting the initial range, however, we do not use the range lines. Instead, we use an instrument called a ballistic unit. It is also linked to the mirror in the head of the periscope. The linkage is indicated here by the arrow. When the range knob is rotated, it causes the mirror to move. The ballistic unit has range scales for various types of ammunition and enables us to fire all types accurately. When the ballistic unit is set at 0 range, the aiming cross in the center of the reticle serves the same purpose as the bore sight cross of the standard dash pattern reticle. Select the scale for the ammunition to be fired. Then rotate the range knob until the proper range on the scale is under the index. Here it is at 1/200 yards for shot ammunition. When the range knob was rotated, it caused the mirror and the reflected reticle in the periscope to dip. Now elevate the gun until the aiming cross is back on target. The gun is now elevated to the correct angle for firing the selected ammunition at the estimated range. Rangefinders are a recent addition to the family of direct fire sights. They are used both as direct fire sights and as range measuring instruments. Like the direct fire periscope, rangefinders have a sagebrush reticle with a fixed aiming cross. It is used in a similar way. In one model, the scales for range and ammunition appear in the gunner's field of view. In another model, the ammunition scale is located on a computer. And the range scale is located on the exterior near the eyepiece. The ammunition knob is used to set the rangefinder for the type of ammunition being fired. Numbers on the scale represent different ammunition, dependent on the muzzle velocity. The code number for each type of ammunition is shown on the ammunition data chart. As the range knob is rotated, it causes the range scale to move past a fixed index, and as we will see later, it controls the ranging reticle. B indicates bore sight point. We index the ammunition to be fired on the ammunition scale. In addition to the scales and the sagebrush reticle, the rangefinder has a ranging reticle consisting of a pattern of lines. The gunner sees them in 3 dimensions, or in depth. The lines of the ranging reticle appear suspended in space, like a flight of geese heading away from the gunner. As the range knob is rotated, the reticle appears to move away from or toward the gunner. The range is determined by moving the reticle until the lower vertical bar appears to be at target range. If we could remove the ranging reticle from the rangefinder, position it at the target range, and view it from the side, we could see that the reticle is arranged in 3 vertical planes, or in depth. This range is automatically indicated on the range scale. The gunner now elevates the gun to place the aiming cross on the center of the target and fires. The rangefinder enables the tanker to accurately determine the range to the target, giving him a much better chance of a first round hit. The last type of fire control is the auxiliary fire control equipment. One of these instruments is the elevation quadrant. 2 types are shown here. Another is the gunner's quadrant. The third type is the azimuth indicator. With these instruments, the gun can be laid for direction and elevation. When for any reason the target cannot be seen in the direct fire sights. Under these circumstances, the tank commander computes the elevation and direction. He telephones this information to the gunner. The direction of fire may be given by designating a reference point and an angular shift. The gunner traverses the turret to the reference point and zeroes the azimuth indicator. He then traverses in the direction and in the amount that the tank commander orders, thus laying the gun for direction. He sets the announced elevation on the elevation quadrant. He then elevates the gun until the bubble is in the center of the vial. The gunner's quadrant, standard equipment in every turret, is designed to check the adjustment of the elevation quadrant before it is used. When necessary, it may be employed to lay the gun for elevation or to measure the existing elevation. Let's review the fundamentals of fire control equipment. There are vision devices for the crew. The direct fire sights are used for laying the gun when the target can be seen through the sights. The direct fire periscope employs a ballistic unit on which range and ammunition are indexed. The rangefinder may be used both as a direct fire sight and as a range measuring instrument. Ammunition and range are indexed in view in one model of the rangefinder. In another model, the ammunition scale is located on a computer, and the range scale is located on the exterior near the eyepiece. The ranging reticle is used to determine the range. Auxiliary fire control equipment is used to lay the gun when the target cannot be seen through the sights. The turret is the nerve center of the tank. You must be familiar with the location and operation of controls to obtain maximum effectiveness of firepower. The tank is a weapon unsurpassed in maneuverability and in striking power. It is unsurpassed in exploiting breakthroughs and in carrying out bold, independent missions. In your hands are the controls of the greatest shock weapon in the ground forces. Forge the Thunderbolt.